So again, good morning all. So my topic is, you can say, slightly mixture of IoT and AI. It's like regarding to theme, but ma'am has suggested artificial intelligence in multiple stances. So I will be trying to cover the basic of IoTs. If you know IoT, what is IoT, how it is working, then we can slightly skip the part. If you don't know, then we can slightly go into detail. Okay. So basically, we are going to build a IoT network. Then we are going to capture the traffic, or you can say traffic log on the backend side. And then we are trying to predict the behavior of devices with the help of machine learning approaches and deep learning approaches. So it's nowadays, it's very like, you can say, well-known problem is in the market. And so many publications and so many projects are already applied to the same problem with the help of network traffic log. So this will be a good topic if anybody want to start their research or anybody want to pursue a PhD. And if you found anything good and you want to ask anything, then you are most welcome. Okay, so let's start the topic. So as ma'am told me about myself, so I'm Gaurav Singal, working as a professor in Netaji Subhas University. I have included my personal email ID and web page, so that I've included my courses, my research publication, my patents, my projects, what I'm doing. And if you also want to include, connect with me on social media, then also I've shared my LinkedIn web page. Okay, so let's see what you understand with the IoT. So what is IoT? Okay, so this is a picture you are able to see in which one fridge is there, and fridge is saying something. Don't forget to buy milk. You can say some message or some like command or some information is dissipating. And when it is dissipating, when a person is living outside, you can say this is a scenario of home. In home, we have a refrigerator. Okay, and a person is going outside. At same time, this fridge is speaking something or notifying something. What you said, is it possible in real life scenario? How many of you are saying, is it possible? Okay, so you can say this is a kind of example of smart fridge. Okay, smart refrigerator is monitoring the quantity of milk. The same time it is checking a person is living outside. Both the things will happen. Then it is just notifying that please don't forget to buy milk when you're coming again to the home. So you can say this is a very simple application of IoT, what we are seeing in the example of smart home. By clapping, the lights will on. By speaking, the lights will off, fan will on, AC will automatically monitor, AC will automatically turn on, turn off. All these things are possible with the help of this IoT scenario. Okay, to implement this application, we need to see what kind of subtask we have to take care. Okay, so first of all, somebody leaving the home. So you have to sense the user. You have to use sensor, or you can say input device. Second thing, you have to sense the milk, quantity of milk. Okay, that help you to again sense the object. It's again input. Okay, it's very simple. When we are taking two input, one input, multiple input, you need to process the input. But this input we want to say. After this input, what we have to do. Okay, so we need to process the information. So after these two information, we need to find a decision. We need to calculate a decision. So based on these two information, we are going to generate a decision. Okay, so basically we need to process this input. So it needs some kind of processor, or you can say microcontroller. Okay, and after that, after making a decision, we have to propagate, we have to inform this decision to the user, to the client. So you can say we'll communicate, we'll transfer the data from one device to other device. So we need a communication medium. A communication medium. So you can say simply from fridge to person. So implement that application, we need to take care all these four subtasks. We need to take care all these four subtasks. So that you can see, again, this is not finished here. We have to see how we can implement each individual step. Suppose you are leaving the home, then what kind of difficulties you have to take care? So what type of sensor you have to use while somebody is leaving home? Any idea what sensor we can use? Anyone?
Participants, please respond.
Okay, like not a compulsory, just like I thought somebody know about that. So maybe like it's new for guys. Okay, so there are multiple sensors are available in the market. Okay, so you can say we have ultrasonic sensor. So basically you can say distance sensor, proximity sensor, or you can say simple, you can use camera. So why not you can use camera? To identify a movement of person who is living, who is going outside. Okay. Second could be to distinguish between parent and children. Who is leaving? A boy, a parent, or a grandparent? What is the reason for leaving home? Maybe he's going for some vacation. Maybe he's going for work. Maybe he's going for some emergency. And identify the other context. What timing they are going? Is it store open? If they are going for office, he will not come by the night. There are multiple contexts is possible in different scenarios. So we have to measure all these four things or multiple things to make the application reliable. Okay, so this is for sensing user. Now we are going for sensing object. So again, we have to check the quantity of milk. What sensor we can use to check the quantity of milk? We can use pressure sensor. You can use some kind of weight. Again, camera is also possible. Okay, Then we can see the previous pattern. Is really milk required right now? Or for the next 24 hours we need something? If it is required, then how much milk is required? After how much time the milk will finish? So here you can use some kind of predictive learning. You can predict the future consumption and future requirement with the help of previous patterns. Okay, after getting these two information, we need to process the information. So to process the information, what kind of processor you will use? You can say what kind of microcontroller embedded device you will be. Node MCU, Raspberry, NVIDIA Jetson Nano. What is required for your project, for your idea? What will be the rule, initial rule you can say? If this happen, then this will do. If this happen, then this will do. Like specific orders to do the task. Okay, and in future, you can replace fixed rule versus dynamic rule according to the previous patterns. You can see the normal inputs we are getting from the IoT, but to know patterns, to know the behavior, to predict the future, need AI. Or you can say the subset of AI is ML and DL. According to your application, according to your data, in use, anything. So AI and ML is nothing if you don't have data. So to work with data, you need IoT. You can say there are already existing data that is there, but if you want to start from scratch, or you want to generate your own data, then you need to understand this kind of applications. Okay, and finally, after these decision or processing, we need to communicate, we need to inform this user about decision, notify. So again, how you would be informing? By alarming, or you can say LEDs, by notification, by message, speaker, anything. Next, when you will reply, what will be the privacy issues? What is the subtleness? And what will happen if information overflow? You are not able to dissipate, you are not able to inform, but still next information is in the buffer. So what you will do if information overflow? So my motive is to implement this small application. You can see how much abstraction is there, and you have to take care all these things to make a reliable application. To make a reliable application. Okay, now we can see what are the building blocks for IoT. Okay, so first of all, there's a thing which you want to make it smart, or you can say object. Like whom we are thinking to make it, we can say device, object or device. Okay, now this device which we want to make it smart or connect with internet, okay, this need some kind of input to process something. Now, if it is sense something, if it will take input something, then we can ask them to do something. You know? So first of all, it will use some kind of sensor. Sensor basically who will sense the environment, who will sense the nearby objects, who will sense the nearby stimulus in environment. So a device will sense something. It will call input. After input, it should be processed with the help of controller. After input, it should be processed with the help of controller, or you can say brain, or you can say simple word processor. Okay. After controller, it will generate some decision. What will be a decision? And the decision will be performed by actuator. This task, this action will be performed by actuator, you can say output device, who will perform the output, who will do the action. So suppose I can just give you example. This is a plant. Plant have one sensor, you can say soil moisture sensor, Arduino sense if this has no moisture, it will say turn on motor. You can say turn on water pump. So water pump will turn on. This is like complete process. Plant is there. We are making a plant smart, sensing the soil moisture, and goes in the controller for processing. The controller will inform to the motor that turn on water pump. This process is complete. But now suppose you want to transfer the data, or you want to control the device from server, or you want to connect multiple plants, and you can say like if by sensing one plant you are also giving water to other plants. So all these things can be processed with the help of communicator, some kind of medium. What could be medium? Wi-Fi. Wi-Fi, Bluetooth, more LoRa, Zigbee, and the IoT. There are multiple communication are possible in the market. So I hope it is clear what is IoT and what are the blocks in IoT. So I'm just showing you one small video, then we'll come to the topic. So how IoT is developed, how IoT is useful for managing the delivery issue, parcel delivery issue. So they have tried to control their vehicle from their office to deliver the parcel. So you are able to see how they are controlling the car trunk with the help of a mobile phone from the office. Generally, when we are going office, on that time the person of delivery guy will come to the house and nobody at home. Then we have to say him like come later or deliver to my neighbor, deliver to some guard. So generally sometime parcel will lost. But in that case, you are keeping a parcel in your personal car, then you can use it later when you're coming back to the home. So this is a benefit IoT can help. Okay. Next, you can see IoT security, how IoT is less secure as compared to other network. Okay. So we are going to give a approach which help us to identify the attack device, or you can say we are able to classify the devices who are behaving maliciously. And we are also going to classify the type of attack, what type of attack your network is going on. So that attack is basically going to identify with the help of previous patterns. What is the normal pattern and what is the malicious pattern of network traffic? Okay, so just I'm showing one more video in which they are showing you how IoT is a boom, or you can say it's again like it's prone for the attacks because of they have less power, less computation power, less resources, less memory. Let's see the video. You have listened like with behavior monitoring of devices, we can control and we can say quarantine the affected devices. So you can say we can classify the devices based on the protocol, based on the applications, based on the data, based on the bandwidth consumption. So there are multiple ways to classify devices, and that help us to control our clients. And we can remove or we can reduce the different kind of attacks if we have a control of each device and we know the pattern of each device. Generally what happens, we know there's one device who is sending 1 KB data in 1 minute. And suppose now it starts sending 60 KB data in 1 minute. So it means this device has some kind of infection. Some kind of malicious activity is there. Okay, so that we can try to identify the device and we can make this device out of network. The other system, other devices will work perfectly fine, and the affected device will not affect through other devices. That is the overall theme of our work. Okay, so you can see by a single slide. So we are trying to do traffic classification that lead to the device classification and attack classification. Help of traffic pattern, we can categorize which device is like this packet is coming from which device, and if normally multiple packets are coming, then who is sending this packet, or what kind of attack is deploying in my system. Application leads to mechanism to categorize the embedded devices who are connected to internet and security attacks in the network with the help of traffic behavior. It will be beneficial to ensuring security, reliability of system, and QoS, quality of service. So you can also be sure like your IoT network or your complete system is working perfectly fine. Okay, so you can see this kind of scenario we have created in our lab. Not the same devices, we have used our local servers, local sensors. Okay, so this kind of scenario we have created in our lab. So what we have done, we have taken a router with local processing, and the processing is connected with internet, and this local router is connected with multiple sensors. In our case, we have connected with 26 sensors. So why 26 sensor? Because we are saying we want to increase the database or increase the data set, or you can say variation of data. Analyze all the behavior, all kind of behaviors. That's why we have connected 26 different kind of sensors with our local router. So suppose they have used multiple kind of cameras, multiple kind of appliances, multiple kind of energy management devices, multiple kind of controllers, and multiple kind of health monitors device. So when all the devices will go through this gateway and go to internet, same time we can take the dump of data, dump of network. The dump of network will help us to analyze what kind of pattern they are sending. Is it okay? I hope this slide makes some sense and you're able to get the main idea behind this topic. Okay, so how we are doing traffic analysis? It's very simple. So somebody like is sending packets. Suppose you can see Alice is sending to Bob, and in between any intruder can see what kind of packet is they are sending, and by seeing the traffic, they can try to identify what kind of communication or what kind of conversation is happening between two persons. So what is the motivation? Because IoT devices are easy to hack and easy to compromise and become a part of botnet. So what is botnet? You can say group of malicious devices, group of malicious nodes. That's why we need to classify the IoT devices. Here the requirements to come to classify the infected device, malicious device who is behaving malicious. Okay, so you can see with the previous scenario of 5 years and the coming scenario of 3 years, your devices, non-IoT devices still remain same. But IoT devices are increasing from this much. You can say in 10 years, it's around 7 times. Because previously we have laptop, mobile, all these things. But now you can say every short gadget, like smart, we are making smart washing machine, smart refrigerator, smart AC, smart bulb, smart light, smart fan, smart watch, smart earphone. All these things are coming with the kind of with the IoT. Okay. So this way you can say if number of devices are increased, then also attacks will be increasing. And again, attacks types is also increasing. We need what kind of attack the system is suffering. It's just for your reference. I have added the classification of attack on IoT. What kind of attacks is possible in the network in each layer. So attacks are also specific to some layer. So some are basically on hardware level, some are basically on router level, some are basically on MAC layer, some are basically on finally application layer, some are basically on transport layer. So it's depend what kind of attack people are trying. So accordingly, the multiple attacks are possible in the IoT networks. So how DDoS is working? It's a kind of attack. I think everybody know about that. Distributed denial of services. I think you know about that. Like if a system is there, I'm not playing this video, and multiple devices are requesting for the resources, then this resource will be unavailable. Making a device unavailable, making a server unavailable, it's a kind of DOS attack. And if the request is coming from multiple sources, then you can say it's distributed denial of service attack. So they are denying for service. Okay. So next come how we can go for the classification, but what kind of issues are arriving when we are going for classification. There are variety of number of devices. And you can say the device is also limited. That lead to the issue for classification. So you will see there are some devices who are sending data in a minute, some are sending in second, some are sending bigger data, some are sending small data. We cannot say we have like 10 different kind of devices. We have 1,000 kind of devices, but all devices are limited. Maybe each have one devices or two devices, not in the bulk. Okay. Next could be overlapping instances problem. It increases as traffic increases. So multiple devices are sending same kind of data, same kind of traffic. Okay. Sometimes devices are event based, but some are periodic. They are sending continuous data on every second, every minute, or every hour. Okay. Next, you can say we have a limited database, limited data set. We don't have much data set, so you can make a reliable machine learning or deep learning model that help us to predict the device, predict the attack. Okay. And finally, if somebody is giving data, then we have to again think about what will be the user security and privacy issue if your data is breached. When we are taking dump of data, it means you are doing data breaching. So again, it could lead to privacy issue. Okay, and next, unbalanced traffic. I think it's very normal thing. Suppose we are classifying some data in multiple classes. For one class, we have huge data, and for second class, we have very less data. Then if we are trying to make the model, then again, always the issue, your model will be biased. So in same, IoT also have unbalanced data. Because if you are saying camera and other devices, so they have like bulk data. And if you are saying small sensors, such as distance sensor or ultrasound sensor, they have very less data. So we have to also make it balance. And the last one you can see, we have to think about if any new device come, if any new attack will come in the market, then how you are going to train the system. And how you are going to train the system. Then again, you need to do the retraining. Then it need to do the retraining. Okay, let's see how we are capturing the packet through protocol, MQTT protocol. So this we are showing how we are doing setup installation. So we are taking one device, it's called Node MCU or ESP8266. Installing this device on Arduino platform. Okay, this is the basically configuration, board manager, library, and updating the packets. These devices we have used in our lab to build this network testbed. We have captured the whole data in our lab because we want to work on the Indian scenario. That's why we have created in our lab. So we are using Raspberry Pi as our local server, or you can say as device. Okay, and this is our clients, or you can say sensor node, who is sending data from sensor to the server. And similarly, we have used multiple sensors, ultrasonic sensor, IR sensor, PIR sensor, multiple sensors we have used to sending data or sensing data and sending to the server. So we have used the MQTT protocol. I'll not go in detail because it's more or less IoT things. So we have used different kind of platforms, different kind of protocols. Give the variety of data. We don't want to stick on same kind of data because we want to make a generalized machine learning, deep learning model. That's why we are coming with different kind of protocols. So we have used MQTT, HTTP, and CoAP. So again, this is about MQTT. MQTT is working in the model of publisher-subscriber model. Slightly different than client-server model. So you can say it could be asynchronous and synchronous also. But in client-server, it's only synchronous is there. Okay, so this is the overall workflow of my work. So what we are doing, we are connecting multiple devices. You can say 26 devices, first device, second device, with my local router. That local router is coming from the Raspberry Pi device. This is all our clients. and this is server. Each device has a separate MAC ID. Each device has a separate MAC ID. They are sending data to the server, and server is sending to the internet. In between communication, we are taking dump or PK file. From the Wireshark or TCP dump. So on this data, we are applying machine learning and deep learning. So let's see quickly what we are trying to make in the network. So this is the installation. This is the experiment setup. This kind of devices we have made. 26 devices. 1, 2, 3, 4, 5. So I also mentioned the name: sound sensor, flame, Hall effect, accelerometer, ultrasonic, LDR, PIR, IR, DST, temperature. So this way we have used multiple sensors. How many? 26 sensors in our IoT network. So this is a complete list which sensor we have used. And we have used with some with MQTT, some with HTTP. So total we have used 26 sensors, 26 different kind of sensors. So we can able to analyze what kind of patterns are used, what kind of patterns are available with a particular device. So in future, if suppose ultrasonic come, then we know what kind of pattern of ultrasonic network is exist. Okay, so this is the basically output of broker, how the data is arriving, and this is the output of publisher. When data start communicating from client to server, in between we are capturing the data with the help of Wireshark tool. Wireshark tool is basically used for packet analyzer, or you can say packet capture. So you can see what time it is sent, what is the source address, what is the destination address, what protocol they're using, what is the length, and what information is stored. This information can be seen in detail here. And this is the hex code of data. So what we are doing, we are dumping this data. We are taking log of this data. So I've just shown the video how this my lab, how we have done the experiment. So let's see how to basically classify the network, classify our devices. What kind of steps we have to take care. So we have applied these kind of machine learning approaches and deep learning approaches in, you can say, over the traffic, network traffic patterns. So we have used both approach, manual attribute and automatic attribute selection. So for manual, we have used KNN, Gaussian naive Bayes, decision tree, random forest, and combination of all these approaches. So you can say ensemble techniques. Okay, and again, after this machine learning, we have also tried with the deep learning approaches with ANN, CNN, and LSTM. I'll show the accuracy graph, which one give the best result, because what we have done in starting in the initial, our data is very less, because they collect for 30 days of whole 24 hour, then we can work on the huge data. But right now we have very less data. That's why our accuracy is mostly good in all cases. We are basically setting up the things. So to take dump of this data, take complete traffic log. We are basically doing all this pre-processing. We are using Kali Linux. Okay, so in Kali Linux we have installed the packages. So we have installed Kali Linux first on Windows. We didn't install in the complete empty system. We have already just, you can say, we have created instance of Kali Linux over the Windows. Okay. After that, we have tried to install SCappy. So SCappy is a tool which help us to process the data. So what is the issue? Right now, we are capturing the data in the PCAP. Right now, we are capturing the data in a PCAP, and we want to generate a CSV file with features. CSV file with features. Okay, so this is the raw data. To process it into CSV file. That's why we are using SCappy tool, which help us to calculate different kind of features from PCAP data. So for the pre-processing, these are the subtasks for the pre-processing. So first is traffic dump, then capturing, then splitting, then flow construction, then feature extraction. These are the 5 subtasks we are doing for pre-processing of data. What data we have captured through network to pre-process the data. So first of all, we are capturing data. So for capturing data, we can use Wireshark or TCP dump. Tools will give us a PCAP file. So this is the basically screenshot of Wireshark. We can choose a particular medium, because we want to specify from which medium we are connecting, either LAN or Wi-Fi. Okay, so that medium will open, and after that we can take a log of data in the form of PCAP. Okay, second step, after capturing PCAP, now you can start splitting the data in equivalent to each class, each device. So you can say we have multiple classes in my data. That's why we have divided the data into these classes. That's the meaning, splitting. Splitting the data into multiple subfiles. Because we cannot process all the combined data. We can process each device data separately. Clear? After that, in each particular device, we need to create a flow construction, because flow are our major features for machine learning model. So flow, basically, you are requesting something will come in response, and then you will send the acknowledgement. So this kind of process, you can say, is the device number 1, device number 2. If you found 3 packets can say it's a kind of flow. Okay, and basically after capturing flow, we can simply say we are able to calculate the features. So this is basically, again, we are showing how we are doing with the help of commands. I just included multiple screenshots. So these are features we have used to train our models. So we have used 12 features. So some are packet level, some are flow level, some are behavior level. So what is packet length, packet source port number, destination port number, payload length, flow duration, flow length, flow ratio, payload length, DNS interval, NTP interval, cipher suites, and domain names. So these kind of features we are passing model for classification and identification of devices and attacks. So after that, we'll go for training and testing of IoT traffic. So I hope it is clear. I will just summarize it. So there are first IoT network traffic, or you can say log. This log is split into multiple files. Then flow construction for each packet, for each request. Then we are generating features, state, flow, behavior. Then we are passing these features to machine learning algorithms. You can use discrete, random forest, ensemble, and a trained classifier. And we get the trained classifier that is trained on our own generated data set. Okay, now what we can do for testing? So it's very simple. This process will be follow same. Initial process will be same. Just the difference, we're not going to train, we are using this trained classifier for testing. We are using trained classifier, what we have just trained before that. That trained classifier will be used for testing the module. It will help us to classify devices and attacks. Classify devices and attacks. Okay, till now any doubt?
Participants, please respond. If you have any clarifications, you can ask.
Okay, so we have used Collab network, or you can say Collab platform, for doing all this processing. So again, it's a very simple thing. We have used Collab platform, importing package, Google Drive for dataset. Okay, then we have basically data type selection and uploading, then mapping, then labeling, encoding, or you can say annotation we are doing. The help of MAC address. Then we are using k-fold cross validation or splitting of data because we have unbiased data. Then we are going for normalization of data. We want to make all data in the same range or same level. Okay. After that, we are training the classifier with the help of multiple, or you can say different machine learning algorithms. After training of data, before that, we are evaluating our model on different parameters that could be precision, recall, F1 score, and also generating a confusion matrix. So this is, you can say, not this is, there are other way we have shown the confusion matrix. Yeah. Okay. Then how can we basically test the procedure? So we have trained the model for 24 of data for 15 days. Okay. Then to test the data, what we are doing, we are taking a log of 2-minute window data. We are taking a log of 2-minute data after every 30 seconds. After every 30 seconds, taking a log of 2-minute data. And then the same process will go with this 2-minute data to test this on trained one. So for training, we are taking 24 data for 15 days. But for testing, we are confused. We are not sure what kind of data is good. Are we taking 5-minute window? Are we taking 2-minute window? Are we taking 30-second window or 1-hour window? If you're taking too big, then it's possible you need a bigger hardware. If you're taking too small, then it's possible you're not able to take full flow or complete parameters. So that's why we have tried our simulation, our experiment on multiple windows, and we have found 2-minute is more suitable as compared to others. So that's why we have taken the test data in multiple chunks of 2 minutes. And that we captured after every 30 seconds. Okay, so this is the basically graphical representation, how we're doing. So this is a test bed. Then we are capturing PCAP file, PCAP to CSV, then combine CSV, then train, and this train classifier we pass here for the same process for classifying the devices. For classifying the devices. So there are accuracy graph. What we have tried, KNN, GNP, DT, RF, ensemble. So you will see in mostly cases we are getting good accuracy, around 99%. At the time, when we are doing, it's basic. We have very less data, but now we are continuously capturing data, so we can make our system more resilient and more reliable. Okay, and if anybody want to work on this same project, then we've included the link of existing data set, what the author have proposed, and this is a base paper from where we got the idea. Okay, and we have also generated our own data set. If anybody interested, so we can also share that file with you guys, so you can start working on that. And if you're also interested, I can also share the code file, so where we have written all the pre-processing and flow constructions and feature identification and applying machine learning algorithm. All the codes I can share with you, so you can also try in your system with small data. And if you're interested, then you can create your own test bed. Okay, so these are references what we have used, and we'll stop here. Thank you. If you found anything difficult or you're interested for any kind of project, any kind of collaboration, then please feel free to contact me. These are my details. Thank you.
So participants can ask your queries.
Yeah, good morning, sir.
Yeah, good morning. Hello, good morning. Hello.
In the way of agriculture.
Sangeeta, your query, it's not audible. Please, you can type it in the chat box.
Yeah, okay, ma'am.
Or you can ask now, because earlier your audio was not clear.
Sir, in agriculture, how to implement the IoT?
So, as you are, I think, seeing various applications already deployed in the market. So, you can say, like, I given you one example in which we are saying we can observe the soil moisture, so that you can say one example. Okay, so you can see the sunlight, or you can say predict the rain, what kind of rain is there. Okay, and what is the possibility the rain will happen. So multiple aspects you can measure in terms of agriculture. Okay, and accordingly you can do different kind of solutions, or you can provide different kind of solutions for the agriculture field. But here what we are targeting if your one of device is behaving maliciously, then we can predict with the help of AI. If you ask in general scenario, that's a different thing. Like you can use all these parameters like rain parameter, moisture parameter, temperature parameter to predict when you have to go for supply of water, when you have to go for give a shade, or cut the crop. I think you are working on leaf disease and all these topics. So you can also predict the patterns on leaves. So what kind of if there is any disease in the plants, then you can also use AI for the classification of disease, and you can spray the pesticide. So multiple applications there in agriculture with IoT also.
Yeah, okay, sir. So wonderful session, sir.
Thank you.
Thank you, sir. Thank you, sir.
Yes, sir, the session was really very interesting, with in-depth explanations delivered with utmost clarity, and also it is augmented with video demonstrations. Really very nice session.
Thank
And
you.
also we look forward to your collaborations, sir, in the future on developing IoT systems. It's actually I'm Mir Shantrani. I'm sorry I didn't introduce myself.
Okay.
So thanks again, sir, for your great support.
Thank you. Thank you.
Sir,